Thank you. You can all hear me? Looks good. Great. Yeah, so my name is Erik Hellman. I come from Sweden, in Stockholm. So I'm going to talk about Android and the WebView and how those two work together. But first of all, let me tell you about this picture here. I have two cats at home. They're sisters. They've been living home together at our home for their entire life. Very cute. But sometimes they get to play together, and it usually doesn't work out well. Things fall down, things break, they break sometimes themselves. So they don't really work well together. But there are these few occasions where they do. And it's super cute, like in this picture. And that is kind of what I want to talk about today. Android and the WebView is something that is often getting overused. The intention of this presentation here is to tell you when you really should be using it and about all the cases where you shouldn't be using it. So let's get started. So yeah, so what else would you really need if you want to show a web page in your app? I mean, you just create a layout, a web view, and you assign it an ID, and then you basically just fetch the web view and you call load URL there. And then you show the stuff. It's done, right? Maybe you have something, you want to redirect the user to a support page, or the user clicks a link or something like that. Yeah, so this is very common. I see it very often. Just the thing is, this is not what the web view is intended for. You're not going to load random web pages with the web view. The documentation actually starts by saying that for the web view. In the most cases, you'd want to do something else. So let's take that first. What is the most common case? If you want to open a web page, well, you shouldn't use this one. Instead, you should use custom Chrome tabs. So most of you have probably heard it, but I'm going to have a very short cover of how it works. The advantage of custom Chrome tabs is that it's actually using Chrome and not just a web view. The web view is doesn't have anything to do with Chrome itself, the Chrome instance installed. And it kind of allows the user also to open it in the actual Chrome application. So there's a lot of things that you can do with custom Chrome tabs that people may be not aware of. The first thing you need to do is just import the dependency. And if you want to open a web page for the user clicks a link or something like that, this is what you do. You create the URL, you call custom tabs intent builder, and build and then launch that URL. That's how easy it is. You can adapt this one. You can set the color of the toolbar, for instance. That's one thing you can do. You can also customize the action buttons that show up in the toolbar very easily, like setting a pending intent to that one, which is nice. Twitter does this, for instance. You can customize the transitions, what happens when you open the custom Chrome tab. So that's also a nice thing to do. And finally, the most interesting thing here and the most useful thing for users is you can preload this so that the page loads faster, so the user doesn't end up with having to wait for a web page to load. And the way to do this is to create an object that inherits from custom tabs service connection. And then you call custom tabs client .bind custom tab service with these parameters. And in the callback on custom tab service connected, you get the client. And on that client, you start by calling warmup. And you may wonder what the 0 there means. It's in the documentation, it says it's for future use. So just leave it at 0. You got to love the APIs you find in Android sometimes. And that means that it starts warming up the whole Chrome instance for you. And then you say, create a new session for me where I may launch this URL. So once you actually load this URL using the custom Chrome tabs API, it will load in a snap for the user, probably. So that's custom Chrome tabs. Back to the web view. The web view is in the package android.webkit.webview. And the first thing I tell you, you should probably not use this one. So the documentation even says that you should probably not use this one. There's several examples here of what you should do instead. Write a progressive web app, send an intent to the installed web browser, or use custom Chrome tabs. So examples I've seen over the years where people have used the web view where they shouldn't. Displaying SVG images is a common thing I've seen. Just convert it into a vector drawable instead, and if you can't do that, try Lottie or something. Login dialogues is also a common thing. Don't use WebViews for login dialogues. Well, in some case you have to, because the backend API is out of your control. The backend team is maybe not very, they're a bit reluctant into making an API for logging in. That happens as well. So sometimes you actually just have to use this one, and we're going to check later how you can do authentication using the WebView. But then the thing I keep seeing is when people actually just wrap a mobile website in their APK. So don't do that. So what should you use it for? And this is the mostly complete list of what you should use the WebView for. It's for displaying local HTML content in your app. And you think, like, okay, that's easy. Why not do the remote ones? Well, the remote ones is running on a server and it's probably a web app, so then you should use it as a web app. This is for displaying local content. It could be like a news app, like like the Guardian has or New York Times. They do this. They download the content locally and then they display it in a WebView. That's a valid reason to do it. Another very valid reason is ePub, like ebooks. Ebooks are HTML format, which is downloaded and is contained in the zip file. So we're going to look at that later as well. So this is the complete list of what you should use it for. Of course, there are exceptions, which always happens, but keep this as your guideline and you should probably be fine. On the flip side of this, you shouldn't try to load and display HTML formatted content in a text view or in other Android views. Don't try to parse HTML. Don't do it. There is a really great Stack Overflow question, which started like this. Oh, I'm trying to parse HTML using regular expression, or whatever you're trying to parse it with. Am I doing this right? And the answer to this question is probably the best Stack Overflow answer you can find online. Starts like this. I'm not going to read it all, but I recommend you to go look at this one. And this is, I want to say with this, don't try to convert your HTML content into regular Android views. Just don't do it. Okay, moving on. So how do you get started with working with web views? The basic stuff here is the first line you're going to write is this one. WebView set web content debugging enabled, and you pass in the build config debug parameter. This means that you can now use Chrome dev tools to inspect the WebView content. You get the JavaScript console you can run stuff in. You can see the network request that the WebView does. It works like this. Once you have enabled that one and you start up your app, you start Chrome, you type in Chrome://inspect, and you get this view. When I was running this at home, I had all my Google Homes popping up as well. But in the bottom there, you see the WebView in that application. And you click the inspect link there, and you come to this view. This is what I'm going to talk about later, the ePub rendering thing. And you get, like, you see the preview of how the content looks like from the screen. Here I'm displaying all the elements, but there is also the JavaScript console. You can check the source code. You can even debug the JavaScript by setting breakpoints. Very helpful tool. Those of you who have been using Steto know that the Steto uses the Chrome the Chrome dev tools to do some fancy stuff as well. But this is for inspecting actual web content. Okay. Second step, add the compat library. You do want to use the web compat library in your application if you're using the WebView. Do not skip on this one. It's very important. This is the Android X version. If you go online and look, you find the non-Android X version as well. Third step, you want to configure your WebView. And this is where people often confuse things because the names of the settings are not very obvious and can be a little bit tricky to get right. So we start with this, the basic settings. If your WebView contains JavaScript, you do want to enable that one. Make sure you know if you need JavaScript or not. And you might ask, why would I need JavaScript? Well, the only way to interact with the web content is through JavaScript. And you don't want to do it from the native side and try to figure things out there. So there's probably some JavaScript running that you want to have this enabled. DOM storage enabled is a little bit tricky. What that means, it means that you can access the local storage and the session storage APIs in the JavaScript. If you need a more complete database, the IndexedDB, you need to say database enabled. And this one, use WebView port, is a little bit tricky. It's a meta tag in the HTML documents that can state the viewport information. If your content has a viewport meta tag, you enable this one. You probably don't want the users to use the built-in zoom controllers, so make sure you disable these. Otherwise, it pops up as a little overlay on the WebView. OK, that's the basic settings. Now, caching. Since I'm talking about loading local content, you just disable the cache. This setting here will make sure that the WebView will never try to load it from the HTTP cache. And the reason you don't want to do this is it will basically just be duplicating stuff. So you already have the content locally, so don't try to cache it locally as well. This one might surprise a lot of you. We're loading local content, but I suggest that you disable loading from file URLs. We're going to see next, a little bit further ahead, how you should do it instead. So all these first three here are about file access. Disable all of those. The fourth one is a little bit weird. It's basically allowing the WebView to load stuff from a content provider. And you probably don't want that. So yeah, disable all of those. Now we're going to display remote content. If you want to do it, you do it like this. Pass the URL in to the load URL function, and you're fine. But as I told before, try not to load remote content into your web views unless you actually have to. The login dialog exception is one of those. So don't do this. Another way you can load content locally is to generate content. So if you generate an HTML string like this, you can you convert it into a base64 format, and you call load data with the base64 data, and you say this is text HTML and it's base64 encoded, and it will load that HTML as a web page. Now, there are cases where you might want to do this. For instance, if you have a license agreement in your resources, string resources or something like that, that is HTML formatted, you can use this method to do it because you're probably not going to include anything else. But if it is the actual web page where you will have JavaScript and loading other stuff, this doesn't work well because of cross-origin policies and a bunch of other stuff that relates to how the web works. So, but this is one way of loading content locally. Now, the actual way you should load local content is like this. Sorry, just stepping through that one. It's like this. You create a URL, and the URL here is the key to the whole thing. And you get your web view, and you call load URL with this URL, with that URL. So let's say your app is about displaying something, web content that's local web content, which relates to your cats application. So you say cats.androidplatform.net/indexhtml. There's no difference here. This is a remote URL, right? We'll get back to that one. So just keep it in mind. First, we're going to talk about the WebView client. And this is the key to loading and controlling what is loading inside a WebView. Now, unfortunately, the documentation for this class is sparse, to say the least. Also, if you check the setter on the actual WebView class in documentation there, it's a bit confusing. Sets the WebView client that will receive various notifications and requests. OK? It's a little bit confusing. There is a little bit more documentation if you read more about the WebView and web content on the Android developer site. But it doesn't really provide you with a full picture of what this one is capable of. So this is the two most important things in this presentation will come next now. That's why, what do you use a WebView client for? It's two things. You intercept the WebView requests, and you override the network response with a custom content. So the intercepting WebView request is useful for capturing auth tokens when you do a login. So if you have a remote login dialog that you can't get rid of, you have to use the web-based one, but you pass in a redirect URL, you can use the intercept request function on the WebView client to do that. And the way to load local content is by overriding the network request. So we're going to look at how to do that. The important thing first is to always use the compat version of this class, which you include in the Gradle dependencies. So use a WebView client compat. Should override URL loading. This only works for GET requests. You should never call WebView load URL or WebView load data in this callback. Avoid that. And the most useful thing here is for capturing auth tokens from login. How do you do that? Well, you get your WebView. You create the instance of WebView client compat, and you override the should override URL loading. And in that one, I check here, did I get the redirect URL that I was asking for? Is that the page we're trying to load right now? If it is, handle this login success. Otherwise, return false, which means we're not going to handle this act as usual. And then you just create your login URL, which opens the login dialog, and load that one. So this is how you do that thing. So it's rather simple case to use it. But remember, if you can get your backend team or whoever provides the thing to provide you with an API instead for use for logging, do that instead. Now, back to that URL. It's at androidplatform.net. So Google has reserved this domain for this specific purpose. So what we want to do is we want to tell the WebView to load data from a URL which uses a domain androidplatform.net. But you will intercept the network request and deliver your local content instead. This means that the web so you trick it into believing that it's actual web content loaded remotely. There is an implementation from Google. You find it on github.com, Google WebView local server. And it works like this. You create your WebView client compat object. You override should intercept request. And in that one, that function gets a web resource request as parameter, and it returns a web resource response. So you can think of this as an memory-embedded web server that doesn't go over the network. There's no TCP socket included here. You create a response with this one, and the create response method would look something like this. We get the resource request, and we return a web resource response. We extract the path from the URL in this request. We figure out which file that maps to on the file system, on the local file system. And if it doesn't exist, we return a 404 response, so the WebView understands that this is not really a real thing. If the file exists, we continue to figure out the MIME type and the encoding of this file. And then we return the real response. Now, this is a very basic and simple load here, like an ePub, for instance, or news article with animations or interactive news articles. It probably is a little bit more. You can, of course, the final parameter to the web resource response constructor is an input stream. So you can stream stuff live to the WebView if you would like to, or you can cache this web resource response as an instance and just deliver the new one every time. Either way, it works fine. You can pass headers into this one as well. I have empty map here. Headers doesn't make sense really because it's more of a server thing, and we don't really parse those. So, but if okay. So that's how you load local content. And the androidplatform.net makes sure that you don't collide on any existing website, so that it doesn't conflict. That's why you should use that kind of a URL. You can just make up your own URL based on that domain. Okay, so we're gonna communicate between Android, the virtual machine, the art virtual machine, and the JavaScript running inside Android. So this is usually a very tricky challenge, and the old way of doing that is done like this. And we're going to talk about that one first, so I can explain to you why that is a problem and why I don't recommend you using that one. So we start by creating a class. We just call it my JavaScript interface. We pass it a handler. We don't have to pass it a handler, but you should do that. And then we have one function here called onEvent. It takes a string. We assume that this string is JSON, so we deserialize it to a JSON object. And then I create a message that I pass into my handler, and I post it away so that I can handle this on another thread. Because this function will be called from JavaScript side on the thread that the WebView is running. So it's not the main thread. You should definitely not block this thread. You should be very careful about that. So we just the native side. And the way we connect this to the WebView is like this. We get the WebView. We create an instance of this my JavaScript interface class. And then we call add JavaScript interface on our WebView. And the first parameter is the instance of this object. And the second parameter is the name in JavaScript that this object will have. So this is the first problem here, your namespacing. You have to make sure that you pick a name that doesn't exist in the JavaScript world. OK. What about the other direction? What if you want to call a JavaScript function from Android? Well, you can do that also. Sorry. First, the JavaScript version of sending sending an event to Android. So in the JavaScript world, we have a function called emit event to Android. In that one, we check if the Android object actually exists. If it doesn't exist, well, something is wrong. We also need to check that the onEvent function is actually a function. If both of these are true, we can invoke that function. We pass in a serialized string of the JSON that we pass in here, and it will be sent up to the Android side. Now, back to that one. How do we do it the other direction? How do we call a JavaScript function from Android? So we have a JavaScript function called performAction, taking a name and an age parameter, and it just returns a string. Super simple, but the case which you can imagine can become more complicated in real world. On the Android side, we have we call evaluate JavaScript, and you actually have the string that you build up matching the actual invoke call. So this is basically an eval function, and eval is evil. So you should not do this. This is bad practice, but this is the only way we used to be able to do this. The evaluate JavaScript call takes a second parameter, which is a callback. So if the function you invoke, or the expression you invoke here, returns a value, the callback will contain that value, will be called and contain that value. Again, there is threading issues here, so you need to consider that. So yeah, this problem has, like, the threading is a problem. There are two different threads. You can't block either of them. You have to be sure to delegate stuff away from that thread as soon as possible if something comes in. You're binding a native object to the JavaScript world, and it's, it gets creepy just talking about it. And also, you're calling functions by string. It's like live eval. It's really bad practice to do that kind of thing. So the new way of doing it, which I highly recommend you to do if you need to communicate between the WebView, the JavaScript in the WebView and the Android side, is by using message channel. Message channel is a standard API in the web world, and it exists on the native side on Android as APIs on the WebView as well. So the way you use this is basically you pass messages in between. So there's no binding of objects. There's nothing you have to release later on and stuff like that. So it's much safer to use. And, well, yeah, you should really use this one. And the way to do this is as follows. You start by calling WebView compat. Again, use a compat class. Don't use the function on the actual platform WebView. You call create message channel. You pass the WebView in here. You will get an array back, which will consist of 2 ports. So what you do next is that you take the first port in this array, and you say set web message callbacks. This is the port that you will use to send messages and receive messages from. You have the on message here, where you basically just deserialize the data you get in, and you handle that one. This is a much safer way to use it, because you can tell it to run on a specific handler from the beginning, so you don't have to delegate it away to another thread. The first thing you do when you have set up this one is to send a message telling the JavaScript side that here is the port you should use to send messages to me. There were 2 ports. So the first port is used by the native side, and the second port you have to send over to the JavaScript side so that it can pass messages back up. And the way to do that, we create just a message. JSON will say type in it. So this is our first message. And the second parameter to the web message compat object here is an array with a single element consisting of the second port. And then you call post message to the WebView. You send the message that we just created. And the third parameter is the origin that this message relates to. If you're only loading local content, you can pass in a star here, and that was fine. Otherwise, if you're more concerned about security, you should learn about how the origin policy works in the web. So it's basically URL otherwise. On the JavaScript side, we do something like this. We create a variable called native port. This will be the port that we will send messages back to the Android side. We create an event listener for the events of type message. And the callback for that event listener will check if the data exists, try to parse the data, and then check if this was an init message. If it's an init message, we know that this message will contain the port that we need to use to send messages back. If it's not, then we just handle this one as one of the other messages that came later. Finally, if you want to send something, you take this native port that we received in the first message and call post message with a string. So now we have bidirectional communication without having to bind any objects, without having to care about threading or anything else like that. OK, so we talked about how to load the local content without having to set up your own web server or using file URLs. We talked about how to intercept the requests and such. And the final thing I want to talk about is, OK, so I got this data, but it's not actually formatted or working as intended. So I need to reformat it. You basically need to adapt the customizing the local web content in some way. And now you might ask, why would we need to do that? Well, ebooks are a typical example there. So ePub is the standard for e-publications, or ebooks, basically. And that is what we're going to look at next. It's the W3C standard. There are the first version was version 2, because version 1 never happened. And there is a version 3 as well, and there is some iteration of version 3, and they are working on a version 4. Basically, an ePub file is just a zip file of a certain structure with local web content in it. Sorry, with self-contained web content. It's basically just an HTML, bunch of HTML files, like multiple ones, usually one HTML file per chapter in the book. There's CSS files, it can be JavaScript, there's images, and there are some XML files which define the content as well. In order to display an ePub, you need custom JavaScript to load, to format it, to inject CSS into it. So that's the challenge with ePub. If you unzip the file, you get something like this. There is a meta-inf directory which contain a meta.xml and a container XML. There is another file usually called something .opf, and that one is the important one. That one contains all the information of what's inside this zip file. And then you see there's a bunch of other stuff. There's CSS, and there is images, and there's XML files. And the XML files here are actually XHTML, because this was a very old ePub file. The package file, and this might be a little bit small. You can check the slides later. I'm just going to mention it. There's a number of sections here, and the first section is the manifest sections in this package file. It defines all the content in the ePub that you're able to load. So, for instance, it defines the ID for each item. It defines the URL for that item relatively to this package file. And it also tells you what the media type is, the MIME type for this file. So it's application XHTML, well, that's HTML for you. It can be a PNG file, it can be a CSS. And there's also JavaScript and all the other content that you're interested in. So this one is basically just defining that one. It acts as like the information for whoever loads this, how it should tell the WebView what this content is. The spine section in an ePub is more important. It defines in which order each of these HTML files comes. So basically, you start with the cover page, and then the title page, and then it comes each chapter section by section here. So this one defines the order of all the HTML files. The item refs in this part has an optional attribute called linear. So if you ever get started with rendering or trying to display ePubs, this one is the first most confusing thing you will run into. It's optional. It's either yes or no, but the absence of this attribute is undefined. If it's linear, it should be included when the user swipes the book and goes between pages. If it's not linear, it might be an item that you can navigate to through a table of contents or something, but it's not something that turns up when you turn pages. But the absence of this attribute is undefined. Most ePubs don't include this attribute. Sometimes they include one attribute, one of the items, which is either yes or no, so you don't know how to treat the other ones. Very confusing, but that's ePub. It's very confusing. Okay, so if you start to scroll, if you open one of the XML files here in this ePub, and you scroll it, it looks like that. And that is not how we want to display the ePub. So how would we do this? If we're loading the web content in the WebView, how can we adapt this so that you scroll it side by side, page-wise, horizontally scrolling? And the way to do that is we start by creating a single HTML file, which will be the thing we load in the WebView at first. It contains the CSS, which is relative for all the chapters. Not the content in each chapter, but like how do we lay out the chapters next to each other. We include the JavaScript, which is basically the application for our ePub reader. And then we have a single element where we will load all the content. And inside here, we will load one iframe for every chapter. So this is how you would render ePub. The JavaScript, and this, it's much more than this, but I'm gonna cover the basics here. You start by fetching the element where we're gonna load the iframes. And then we go through all the items that we have from our spines. So we have parsed the XML, we have parsed the information about the spines to the JavaScript side. And so we know that one, we know the URLs for each of the chapters, we know the MIME type for all the content, etc. And for every item, we create an iframe. And for each iframe, we append it to the resource root, so that it will be a number of iframes inside that one. And then we tell the iframe, okay, here is the URL that you're gonna load for this chapter. Now, when that item has been loaded, we get an event. So the load event is triggered. And inside there, now we're gonna inject the CSS that is relevant for that chapter. And we create this CSS ourselves. So first we create the link, which is the HTML element that you use for including style sheets. We define the attributes for that one and set those. We set another callback, a load callback for this one, for listening for the load events on this element. That's a nice thing to know in JavaScript. You get a load event if you add an element to an existing document, because everything happens asynchronously. we define where is the CSS that we're going to use for this chapter, and then we basically fetch the head element inside that iframe, and we append our CSS link into that one. So now we injected a CSS into our chapter. The CSS for rendering an ePub column by column like that looks like this. There's a little bit more you probably want to do. You want to set margins, and maybe you want to treat images differently so they don't overflow, etc., etc. But basically, this is the thing. Through CSS, you tell it to don't over scroll. So when it reaches the end of the page, just flip it over. So that you will basically have chapters going like that in the column. But each column will take up the exact width of the web view, so the entire page, basically. Who wants a live demo? How does this look like? So this is the app we have been working on. This is one ebook, and it's all of this text you see here is HTML content. And I'm scrolling this using the JavaScript APIs. And if I go page by page, now I'm inside a chapter, and I'm going to scroll to the end. That was the last page there. So now I switched. So this is scrolling between two iframes. So I have all that logic. All of that thing is happening in JavaScript. Now, at the same time, the last page here and the percentage here, these are Android text views that I positioned in below there. So the only web view thing is the actual text here. And as you see, this one is updated, and I update that by basically passing a message from the JavaScript side up to the native side saying, okay, I've scrolled this much in the chapter right now, so I have this many pages left. And the same thing, if I click here, I just show the Android components for the menus and settings and stuff like that. And I also have this dark mode thing, so I can set the dark mode here. Get that kind of effect and stuff like that. So what I do is for setting the colors here, it's a combination of CSS and setting filter on the Android view. Okay. Back to there. Do's and don'ts, gonna finalize with that one, is don't run a local web server like a real web server with a TCP port open. Just don't do that. It's really bad. It's bad for security. Since you probably can't have a certificate on that one, it will be unsecure, so you need to have that in your Android manifest. Tons of problems with running a local web server. Do not do that. Don't scroll web content from the native side. Don't scroll it inside the web view. Don't try to do that from the native side. Instead, if you need to do custom scrolling inside the web view, do it from JavaScript instead. It's okay to place multiple web views in a recycler view if the content inside doesn't scroll. Avoid multiple web views if you can. Of course, there are exceptions to this as well, depending on your content, etc. Using iframes inside a single web view will probably be a better performance, better for your performance. But of course, this one, you need to compromise depending on your content. Use the message channel for bridging, and use the WebView client compat for loading local content. You can go to the GitHub repo for the Google project, and you can find that one there. Remember, the WebView is auto-updated. So when Chrome is updated, the WebView component in the phone is also updated. This is true from Android 5. Lollipop. So before that, I think it's you're out of luck. But this is also why you want to use the compat library, because then you can do like graceful fallback and stuff like that. So if you can, use the latest web APIs in Chrome. For instance, if you're going to do custom scrolling and custom gesture detection in JavaScript, you use pointer events. You don't use touch events or mouse events. Use pointer events. But just look at all the recommendations for what's the latest stuff in Chrome, and you can use those, which is nice because you don't have to rely on older browser usually. Some other resources here. There is a native bridge written by a Norwegian friend of mine which is a cross-platform component both for Android and iOS. It uses the old way of communicating between Android and the WebView. But if you want to have something that works cross-platform, it's nice. Again, the link to the GitHub project for the Google local web server. You probably want to adapt that one, but it's very easily to see how they have done it and use it for your own things. So thank you very much for listening. It's time for lunch, at least for me. Nice for you to all come here.